fuck is this? This is bullshit. Are you two fucking around in school again? Hey, we got to pay for this shit. Oh, shit! Oh, shit! No! That's not happening right now.
How do we listen? Elmo knows how. With our whole bodies. Let Elmo show you how. 1 year ago, world leaders launched a global solution to rapidly end the pandemic and equip countries to fight this devastating virus. The Accelerator supported research continues to find the next generation of tools. But the pandemic isn't over. Societies and economies are still suffering. Our safety and security is still at risk. And history is still in the making. It's time to recommit to act together. Let's take research, production, and distribution up a gear to keep everyone, everywhere, safe from COVID-19.
How small is the smallest piece of technology you can imagine? The size of a grain of rice? A grain of sand? How about the width of an individual strand of spider's web? A red blood cell? Narrower than a single wavelength of visible light? Okay, now we're talking. Welcome to the realm of nanotechnology.
And we've done this very, very quietly, but we're glad to now release it to the world, is this idea of Teslaphoresis. Teslaphoresis is, the simplest way to understand it is self-assembly at a distance, just long-distance assembly of materials. And what we did was, because we're at Rice, we had plenty of nanotubes around, so we decided to use nanotubes. And what we discovered was that these nanotubes can actually string together and form wires by themselves under this electric field.
Carbon nanotubes are, unsurprisingly, tiny tubes made of rolled up sheets of carbon a few nanometers across with a honeycomb-like structure. They can be created in a bunch of cool, sciencey ways, by inciting reactions in graphite using gas, by blasting it with lasers or plasma, or zapping it with electricity.
Teslaphoresis is one of those things, it's a project that there are just so many avenues, so many things that I think you could do with it. Not just making conductive wires, but taking it in so many different places, not only just biomedical and engineering, but taking it into different industries like silicone chip.
Taking it in so many different places, not only just biomedical and engineering.
Consider the idea of injecting blood cell-sized nanobots into a patient's bloodstream.
And this is my field. My expertise is in the fields of physics and electrical and computer engineering. That was a serious challenge because it's well known that communication between neurons and the other cells in the internet of the human body is driven by electric signals. So the only way you can do it by physically attaching contacts to all the 80 billion neurons in the brain. Of course, you're not going to have 80 billion wires coming from the brain. The brain is not going to work, right? So we had to figure out how to do it wirelessly. That was very important to us. So our claim was technobiology is more fundamental. Technobiology deals with laws of physics, which underlie the principles of biology. So what we did, we used those nanoparticles to apply wirelessly special electric fields which perfectly match the properties of the cell lines. But what's special about the nanoparticles we used is they're called magnetoelectron nanoparticles. Magnetoelectric property allows us to communicate with the cells wirelessly.
Magnetoelectric property allows us to communicate with the cells wirelessly.
Unlike any other nanoparticles, these particles can sense two different fields, electric and magnetic, at the same time. Only recently the materials like this were invented, and we were the first group who implemented this in medical applications. So what it means, these nanoparticles can sense electric fields, and electric fields, as you know, they're generated by electric charges. And at the same electric fields are important because the electric fields is the language which cells use to communicate with each other. And at the same time, they sense magnetic fields. And magnetic fields is a language which can be used by us. The magnetic fields are known not to interfere with the complex electric circuitry of the brain. So they can be used for perfect wireless control.
Nanotechnology comes with some areas of concern. Nanoparticles are classed as UFPs, ultra-fine particles, and we've only just begun research into how to regulate these as nanotechnology evolves. There are medical concerns. Could nanoparticles cross into your bloodstream or into your brain?
In this case, what we do, we administrate the nanoparticle intravenously. So we give one painless shot an hour before the treatment. The shot is similar to the typical flu shot we all use.
In this case, what we do, we administrate the nanoparticle intravenously. So we give one painless shot an hour before the treatment. The shot is similar to the typical flu shot we all use. The shot is similar to the typical flu shot we all use.
In there. And when the particles get in the blood system, we can see them on the screen of our computer. We know where they are. We can wirelessly make them go any way we want. We can see the circuit in the brain. We can zoom it in with the precision of one neuron, if necessary. And we can repair the circuit if required. And that's exactly what we did. Optionally, you can actually use administered particles orally. You can mix them in a glass of water, drink it 1 hour before the treatment, and the same thing happens.
Use administered particles orally. You can.
Last night, we received promising news about another potent and potential COVID treatment, a pill developed by Pfizer that may dramatically reduce the risk of being hospitalized or dying when taken shortly after infection, if you're infected.
Optionally, you can actually use administered particles orally. You can.
If authorized by the FDA, we may soon have pills that may treat the virus of those who become infected. We have already secured millions of doses, and the therapy would be another tool in our toolbox to protect people from the worst outcomes of COVID. But look, it's important to remember, we need to prevent infections, not wait to treat them once they happen. And vaccination remains the best way to do that. The pandemic is not yet behind us, but within this week's announcements, vaccines for kids, more adults getting vaccinated, potential treatment for those who get sick, we're accelerating our path out of this pandemic.
The pandemic is not yet behind us, but within this week's announcements, vaccines for kids, more adults getting vaccinated, potential treatment for those who get sick, we're accelerating our path out of this pandemic.
These particles act as messengers, which can translate for us the language, intrinsic language of the cells, of the neurons, and allow us to see what actually happens with electric signals at the level of each neuron. And we're talking about 80 billion neurons here, because particles are so small and so many of them. And we can see them on the computer, on the screen of our computer. And we can control them, we can do them, we can make them do anything we want. We know we just scratched the surface. Currently, we work with many researchers in this country and worldwide. And every day, we're getting closer to the ultimate goal to use it on people. And we hope within a couple of years, we can do that. And thank you.
Here we can see a chart that looks at the total world population over the last several hundred years. And at first glance, this is a bit scary.